So we're going to look back at some exponent properties here. We're going to start with what happens when exponents are zero or negative numbers. So to help us remember what that does or how that works, I've got some lists of numbers raised to various powers. So we can see 5 raised to negative 3, negative 2, negative 1, 0, 1, 2, and 3 as their exponents. I'm going to start down here with the bottom of the list because that part where the exponents are positive is what we should be already pretty familiar with. 5 to the first power just means take one 5. So it's just 5. 5 to the second power means 5 times itself twice. So 5 times 5 is 25. And then 5 to the third power means 5 times 5 times 5. So that comes out to 125. So as I look at this list, I notice that as I continue forward here, making the exponent higher and higher, I'm multiplying by more and more 5s. So if I wanted 5 to the fourth power, I just multiply by another 5, and so on down the list as far as I want to go. But what I'm more interested in is what happens when I go in reverse, because I want to get back to what the zero power and what the negative exponents do. So when I think about what's happening as I reverse this list, I'm actually dividing by 5. 125 divided by 5 makes 25. 25 divided by 5 makes 5. So if I want to keep going in reverse, I'm going to keep dividing by 5. If you think about it, that kind of makes sense. Multiplying by 5 moves forward in the exponents, so dividing by 5 should move us backwards. So if I take this 5 and divide it by 5, that would be 1. So 5 to the 0 power is 1. Then I divide it by 5 again. So 1 divided by 5 is 1/5. Then I divide that by another 5. Now when I divide by another 5, that effectively is just going to add another 5 into that denominator. So it's going to be 1 over 5 squared, because we're going to have 2 5s down there now, which makes 1 over 25. And then 5 to the negative third power puts a third 5 in the denominator, because we're going to divide by 5 again, which comes out to 1 over 125. So notice there's a relationship between these. As I look at the matching pairs here, 5 to the positive third power is 125. 5 to the negative third power is just 1 divided by that. 1 divided by 125. So the negative exponent basically just created the reciprocal of the positive exponent. Remember that word reciprocal means if I have a fraction, I flip it over. So this one right now is technically 125 over 1. If I wanted to flip it over, that's 1 over 125. So as long as I keep going backwards in the negative exponents, I'm just going to keep dividing by more and more 5s, putting more and more 5s in that denominator. Okay? Let's look at these 2's. Works pretty similarly. So 2 to the first power, we're going to start there, is just 2. 2 to the second power, 2 times 2 is 4. 2 to the third power, 2 times 2 times 2, that's 8. So if I'm moving forward in this list, every step is just multiplying by 2. So if I move backwards in the list, every step is going to divide by 2. So as I move up to this one, 2 to the 0 power, dividing by 2 gives me a 1. 2 to the negative 1 power, take 1 divided by 2, that's just 1/2. Divide that 1/2 by 2, a half is a 4th, which we could say is 1 over 2 squared, or 1 over 4. And then 2 to the negative third power is going to be 1 over 2 to the third power, or 1/8. Now this middle column here is a little bit trickier because these show the exponents on the bottom. But the idea is still going to work out pretty similarly. As I look at this 1 over 3 to the first power, I'm going to start there just like I have on the others. Well, that 3 to the first power is just 3, so 1 over that, we're still going to have 1/3. Then I put a 2 power on that 3. 1 over 3 squared is 1/9. 1 over 3 to the 3rd power, 3 to the 3rd power is 27, so this is going to be 1/27. Now this one's a little different from the other ones because the other ones, as I moved up, were multiplying by 3. This one, as I move up, is actually dividing by 3. 1/3 divided by 3 is 1/9. 1/9 divided by 3 is 1/27. So if I want to move backwards, I have to multiply by 3. Since these 3's were in the denominator, they were already division, so if I want to go the other direction, I have to multiply instead. So 1/27 times 3 is 1/9. 1/9 times 3 is 1/3. 1/3 times 3 is 1. 1 times 3 is 3. 3 times 3 is 9, which notice would be the same thing as 3 squared. And multiplying that by another 3 would take us to 3 to the 3rd, or 27. So notice that when these were on the bottom now, the negative exponent effectively moved them to the top. So 1 over 3 to the negative 1st power is just 3. 1 over 3 to the negative 2 power is just 3 squared, makes 9. So that leads us to these 3 rules over here. For any value of a except for 0, we have 3 basic rules that we should know. A to the 0 power is 1. We saw that everywhere where we were dealing with a 0 exponent. All of those came out to just being 1. A to the negative n power is 1 over n, a to the n. So when I did like 5 to the negative 1st power, that's 1 over 5. 5 to the negative 2nd power, 1 over 5 squared. Same thing worked with this 2. This one shows us what happens if that negative power was already on the bottom, and that effectively moved it to the top, which we were seeing happening with these problems over here. So that's a quick review of what 0 exponents and negative exponents do to numbers.